Hi, this tutorial we're going to look at how to solve system of equations or simultaneous equations. We're going to look at two variables. So with this method, we can use either substitution method or elimination method. So let's look at how to solve them. I know that with this method, we normally, like if you are in the SHS or high school, you will just use the calculator to solve it. But we are looking at the situation whereby you are not allowed to use the calculator. So how do you solve it? So let's say you are given two equations like this, where we have two variables to find. We are supposed to find x and then y. And in every equation, if there is one variable in the equation, you just need one variable. Sorry, you need one equation to solve for that particular variable. For example, if you are given, let's say, x plus 3 is equal to 5, because there is only one variable, you only need this equation, just one equation to solve it. But if there's the case where you have x plus y is equal to 7, this is one equation and there are two variables. You can't just solve this equation alone. It's not possible, but you need two equations to solve for two different variables, and they must be related, and they have to fit into each other at the same time. That's why we call them simultaneously at the same time. All right, so let's see how we're going to solve this question. So first we write solution. Now let's label each of the equation as let's call this one equation 1, then let's call this one equation 2. Because I want the video to be short, I'm going to stick to one method. We're going to use the elimination method throughout. So with the elimination method, all that we need to do is that we are going to ensure that one of the variable has the same coefficient as the other in both equations. So let's take the variable as x. The coefficient of x is 1. The coefficient of this x is also 1. Let's take y. The coefficient of the y is 1, and then the other one too is also what, 1. So we can say that we can decide to eliminate any of them. The ones with the same coefficients, you can eliminate them easily, but it is better to eliminate the ones with one having positive and one having negative. Do you understand what I'm saying? So for in this case, x is the coefficient of the x here in equation 1 is positive. The coefficient of the x in equation 2 is also positive, so it wouldn't be advisable to eliminate this. But if you look at the coefficient of the y is positive 1, and the coefficient of the y in the second equation is negative 1, so you can try to eliminate the y first. When we say eliminating, meaning we are getting rid of that variable in the equation for the meantime, then we bring it back later. So what we do is that we're going to add them. The reason why we are adding the two equations is because when we add them, the y will cancel out, because if you have positive y plus a negative y, they cancel out. So let's just add equation 1 plus equation 2. So equation 1 plus equation 2. So this equation, the x plus the x gives us 2x. Positive y plus negative y will give you 0. So that goes away. Then we have 10 plus 2 giving us what, 12. So we here to solve this, it's so easy. We can get x to be what, 6. Now that we've gotten x to be 6, all that we need to do is to substitute the x equal to 6 in any of the remaining any of the equations. So we can decide to substitute x equal to 6 in equation 1 or equation 2. So let's say we are going to substitute x equal to 6 in equation, let's say equation 1. So what we do is that we say this is equation 1. This one was labeled as equation 1. So x is 6 plus y equal to 10, meaning y is equal to what, 4. So this implies that our equation, or the solution to the system of equation, x becomes 6 and then y becomes what, 4. And we can test it out to see if the answer is correct. If we say x is 6 plus a y which is 4, we get 10. And an x which is 6 minus a y which is 4, we get 2. So it means that the solution is correct. Then move on to the next question. So this is our second question, and in this case, just as we did in the previous one, let's label this as equation 1 and then equation 2. Now we look at the coefficient of each variable. The coefficient of x is now different, which is 2. And this, in the second equation, the coefficient of this x is 4. So they are not the same. We cannot eliminate them. We have to, before we can eliminate them, we have to do something to them before we can eliminate. But let's not think about that for now. Let's come here. Now the coefficient of the y is positive 3. Coefficient of this y is negative 3 in the second equation. So because their coefficient is the same, we can easily eliminate them. Then we have 12. No, this one don't even have to look here. So what we can do is just that we did in the previous example. We're just going to add the two equations. We're adding them because 3y plus a negative 3y will give us 0. So if the coefficients are the same and one carries a positive sign, one carries a negative sign, when we add them, they just cancel out. So we will just say equation 1 plus equation 2, going to add them. When we add 2x plus 4x, we get 6x. Then this goes 0. Now when we add this, we are going to get 18. And we see that our x becomes 3. That becomes the solution. Now, since we know x to be 3, we can substitute that into any of the equations. And in the previous one, we substituted it in equation 1. So we're going to, this time, let's substitute it into the equation 2. Just for the trial, okay? For you to know that in any way you do it, it's still going to be correct. So we have 4 going to multiply 3. This is our equation 2, okay? We're not going to get rid of this, so note that this is the whole of equation 2, so we need to include the negative 3y. All right, so this is it. Then 3y equal to 6. So 4 times 3 is 12 minus 3y is equal to 6. Then we group like terms. We have negative 3y is equal to 6 minus what? 12. That's 3y will be equal to 6, and then our y becomes 2. So that becomes the solution. So we have the solution becomes that x is equal to 3 and y becomes 2. So let's test and see if the answer is actually correct. So if we have 2x, which is 2 times 3, that gives us what? 6 plus 3 times y. 3 times y is 3 times 2 is also 6. So we add them, we get 12. So the first part is correct. Now let's check for the second. Now 4x. 4x means 4 times 3, which is 12 here, minus 3 times y. 3 times y is 6. So we subtract, we also get 6. It means that our solution is also correct. Let's move on to the next question. All right, so this is our third question. Now, this is not like any of the ones you solved earlier. So let's look at how to solve it. So to solve this, what we need to do is to write this nicely. So let's write it in such a way that this moves to that side. We get negative 3y, negative 2y rather, is equal to 0. Okay, then we can have x plus y being equal to 12. So we call this one equation 1, and we call this one our equation 2. All right, so let's look at the coefficients. Here, you realize that the coefficient of the x here is positive. Here is also positive, and it's 1. So the coefficients are the same. Now, when we look here, we have negative 2, and here we have positive 1. So they are not the same. So like I said, the first you need to do is to check the coefficients of the variables. So we can see clearly that it's only the x that are the same, even though, but they don't have opposite sign. Yeah, so what we can do is instead of us to add, we rather subtract. When we subtract, what happens is that you're going to get x minus x. So we get 0. Then we are now eliminating the x rather. So like I said, we rather eliminate the ones with the same coefficient. The variables with the same coefficient, that's the ones we eliminate. So x is having the same coefficient, just that they have they have the same sign. So we need to like subtract to get rid of the variable. But if the sign were opposite, we just have to add them. Hope you get it. Just as we've done in our previous examples, the signs were opposite, so we just had to add them. All right, so let's see how we're going to solve this. So we're going to have x minus x. That gives us 0. So this x goes away. Then we have negative 2y minus y. Negative 2y minus y should give you negative 3y. Negative 3y. So don't go and say negative y. So that you should be very careful. Then you have 0 minus 12. 0 minus 12. It's like the 0 minus 12. That should give you negative 12. So it's equal to negative 12. So we know our y is going to be positive what? 4. Because if we divide both sides by negative 3, you're going to get 4. I hope you get it. So let's move on to the next one. Let's see how we're going to solve for the x. Now that we have found what y is, we're going to substitute y equal to 4 in any of the equations. So we can decide to substitute it into equation 1 or equation 2. This is equation 1. This is the same as equation 1. Okay, this and this is the same. So I would like to substitute it into this so that it becomes easier for us to solve. So we're going to have x equals 2 into brackets, y is 4. So x becomes 8. Very simple. Hope you get it. Let's move on to the rest of the examples. I'm just going to give them to you so you try them. Then we solve special ones. Alright, so I've given you 2 questions for you to try. I'll write the answers for you, but what you need to do is to just pause the video. You solve it by yourself. Then you compare your answer with what I'll write here to see if it's the same. If it's not the same, maybe you can leave a comment or a question in the comment section, and then I will assist you. The same thing applies to this one. So you pause the video now and then you try it out. So the answer to the first question, the 3x plus 2y, this one, the x is going to be 2.5, it's 2.5, and then 4.25. That's going to be the solution. And then this one, x is going to be 4, and then y is going to be 1.5 when you solve that. So solve it and then confirm the answers here, and then let's see. Now let's solve some special cases. Okay, now the case whereby, just as I've given you in the previous the try work, you can see that the coefficients of the x are not the same. The coefficient of the y are also not the same. So what do we do in this case? What we do is that we have to make them the same. What can we do to make them the same? So you look at which of the variables is easier to make them have the same coefficient, and the only thing we can do is to multiply or divide. Now you will agree with me that if I divide here by 2, divide here by 2, and divide here by 2, I mean I divide the whole of equation 1 by 2. Let me call this one equation 1, call this one equation 2. So if I divide the whole of equation 1 by 2, it will make the coefficient of y equal, just that I'm going to get decimals here. You understand that? Because I'm going to get 2.5 here, and I think I'm going to get 15.5 here. Yeah, so I wouldn't want that, even though it's going to make my variables the same here. But what I can also do is to multiply. Like I said, you can only multiply or divide. So I can also multiply equation 2 by 2. In that case, if I multiply this by 2, I'm going to get a negative 4y. So that the variables are also going to be the same. You understand? So you can do that. So I will prefer to. You can do any of them. If you think you can work with decimals easily, that's fine. So I'm going to multiply. So I'm going to multiply equation 2 times 2. That makes this 4y. So the equation 1 is going to be maintained at 5x plus 4y is equal to 31. If I multiply 3x by 2, I get 6x, then negative 4y, then each term. So don't forget, you want to multiply every term here by the 2. So 7 2 is 14. So now this is now our new equation 2, and this is the old equation 1. Now from this point we can solve it easily because the coefficient of this variable, the y variable, are the same, and the good thing is that they are even having the same what, they're having opposite sign. That's here is having positive and here is having negative, so we can just add them. So when I add this and that, I get 11x. This will cancel because 11 positive 4y plus negative 4y gives me 0. And if I add this, I'm going to get 45. Now I'm just going to divide both sides by 11. So my x becomes, so we get 45 over 11. And this is a proper fraction. You can leave it in decimal. So, or mixed fraction with it 4 whole number 1 over 11. Or in decimal as maybe 4.09 or something like that. So I think it's better you do it like this. Now let's move on to next. So what we have to do is to substitute the x equal to 45 over 11 into any of the equations. So let's fix it into one of the equations. So let's fix this into the first equation, our original equation 1, which is 5x plus 4y equals 31. But we know that x is 45 over 11, so we're going to have 5 into bracket 45 over 11 plus 4y, that should be 31. So when we multiply 45 by 5, we are going to get 225 over 11 plus 4y is equal to 31. Let's multiply through by 11 so that we just get rid of the 11 here. So we can get multiplying through by 11. So 11 times 11 times 10 times 11 like that. So we can get 225 plus 44y. Then 31 times 11, that should give you, that's 314. So what you do is you just write, there's a trick to it. So you just write 3, you write 1, then you add the individual digits and then you put it in the middle. That's it. So we just group like terms. We get 4y to be equal to, sorry, 44y is equal to 341 minus 225. Solving that should give you 44y should be equal to 116. Divide both sides by 44. Divide both sides by 44. This can be simplified. So let's simplify it and see. What number can go? That 2 can go. I think 4 can, no, 4 cannot go. 4 can go because the last two numbers are divisible by 4. So 4 can also go. So we can divide, can use 4 to divide. 4 can go here. That's 29 times. I think 4 can go 11 times. So we have 29 over 11. So there's it. Note that when if the last two digits of a number is divisible by 4, it means that that whole digit is divisible by 4. So we use 4 to divide it, and that's it. So we can leave the answer like this, and then this becomes our x. Therefore, x becomes 45 over 11, and y becomes 29 over 11. So like I said, this is a special case where you have to do a lot of work, but the understanding should be there. That's it. Let's solve one more question, then we can end it. One. So let's call this one equation 1, call this one equation 2. This one there won't be any fractions, so that's the good news. First we check the coefficients. Coefficient of x 1 and 2, coefficient of y 4 and 3. So it means that none of them has the same coefficient. Therefore we need to do something, either divide or what, multiply. If I decide to divide this by something, there's no, unless I divide this one by 2 by 2 by 2, so that the coefficient of x becomes 1, and this one will give me a decimal, this will also give me a decimal, so it will not be advisable to divide because I don't want to work in decimals. That's the reason. But we can multiply. If I just multiply, I am choosing to eliminate my x because that is having a smaller coefficient. I can decide to still eliminate my y by multiplying here by 4, so that I get 12 here, and I multiply here by 3. The whole, don't forget, if I say it here, I'm not referring to just this specific term, but I'm referring to the whole equation. So if I multiply this by this whole equation by 4, this becomes 8, this becomes 12, and 7 4 28 here, it becomes 28. Then here, if I multiply this whole equation by 3, I will eventually get this to be 12y. Then it means that I can eliminate the y easily. However, it's easier for me to multiply here by 2, this whole equation by 2, so that I get 2x and I get a smaller numbers here as 8y, and then let's say here 2. So it's easier to work like that than using the 3 and the 4. And it also gives you a lot of work because after multiplying here by 4, you're not done. You need to also multiply here by 3 so that their coefficient becomes the same. So it's easier we work with this guy. So let's take the x. Sorry, let's just do it straightforward. So let's multiply all this equation by 2. So equation 1 times 2. So that should give us 2 times x is 2x. 4 times 2 is 8y. Then 1 times 2 is just 2. So this is our new equation 1. And then the old equation 2 is still the same. Now, because the sign the same. They are both positive. What we need to do is to subtract rather. We don't need to add, because if we add, we are going to get 4x. So we need to rather subtract. So it's going to be this term minus this term. So subtracting, and in some cases you can decide to even multiply by -2 so that you get negative here, and it will just be straightforward for you. You just have to add. But since we've already multiplied by +2, let's go ahead and then add. So I have, sorry, subtract rather. So we have 2x minus 2x, we get 0. Then we have 8y minus 3y, that should give you 5y. And then 2 minus 7 should give us -5. So our y becomes -1. So now we know our y. So let's substitute y equal to -1 into any of the equations. So let's take our original equation 1 and do that, or maybe the equation 2. Any of them will work. So I'm using the equation 1 because that one looks simpler. So let's say we have x plus 4 into brackets -1 is equal to 1. X -4 is equal to 1. So x becomes +5. You get it? So this is -4. We move here, we get +5. So the solution is that our x is 5 and our y is -1. Hope this video was helpful. Thank you.